Okay, so we're going to work on understanding arithmetic sequences in this video. Well, really in this whole lesson, but we'll start here. Is the sequence arithmetic? If so, what is the common difference? What is the next term in the sequence? So we're given a sequence of numbers right here. 3, 8, 13, 18, 23, comma, dot, dot, dot. So any pattern formed here with these numbers, with that dot, 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 tells us that pattern will continue on, and we can find the next number, the next number, the next number, and so forth. So we're asked to answer the question, is it an arithmetic sequence? So it would help to know what that is. So let's put that definition in our notes. Okay, so an arithmetic sequence is a sequence with a constant difference between consecutive terms. Is it increasing by the same amount? Are we adding a constant term every time? And then a common difference is you're going to see that term come up. That is the constant difference in the arithmetic sequence. So this constant difference defined in arithmetic sequence, we call that the common difference. So let's see what we think if this sequence is arithmetic. If so, what's the common difference? What's the next term in the sequence? All right, let's take a closer look and just kind of let me explain how this works. So the first term of our sequence is 3. So when it says term number 1, 2, 3, 4, 5, 6, the 1 stands for the first term, the 2 is the second term, the 3 is the third term, and so on and so forth. So we can fill in the first term of our sequence is a 3. So the term number, first term, what is the actual term? 3. The second term is an 8. The third term is 13, the fourth term is 18, and the fifth term is 23. So what we want to look for is, are we increasing by the same amount? To get from 3 to 8, and then 8 to 3, 13, 13 to 18, 18 to 23. And you may already have noticed, to get from 3 to 8, all we're doing is adding 5. So are we adding 5 every time? To get from 8 to 13, adding 5. 13 to 18, adding 5, 18 to 23, adding 5. This is the common difference. If you are adding a constant difference like that, we usually denote that with a D. Our common difference is 5. So following that logic, we know that if we add 5 to the fifth term of 23, we'll get the sixth term. So our sixth term, when we add 5, we get 28. So the question we were asked, is the sequence arithmetic? Yes, it is. Because it had a common difference, it's arithmetic. What is the common difference? We found that to be 5, and positive 5 because we're adding 5 to get from one to the next to the next. If we were going down and subtracting, then we would have a negative common difference. And then what's the next term in the sequence? 28. All right, how could you write a formula for finding the next term in the sequence? So when you have an arithmetic sequence, there actually are two ways to write formulas for them. One of them is called an explicit formula. So we're going to write the explicit formula, and then right below, the other kind is recursive. So you can have an explicit formula and a recursive formula for the same sequence as long as it's arithmetic. It's kind of like saying you could write an equation of a line in point slope form or slope intercept form. It's the same line, just different ways of representing the line. Okay, so an explicit formula has a specific form. It follows the form a sub n, so a little subscript, a sub n equals a sub 1, that's the first term of the sequence, plus the common difference times n minus 1. And this n stands for whatever term. Is it the third term, fourth term, fifth term? So it could be a 2, 3, 4, 5, depending on the term you're talking about. So why don't let's maybe define that so we have that in our notes. Maybe over here. A1 is the first term. D is our common difference, which we wrote above, but we'll put it here. All right, so if you know the first term and you know the common difference, you can write an explicit formula. In this case, our first term was 3. So again, these are the term numbers. So the first term is a 3. So A1 equals 3. And then our common difference was 5, a positive 5. We talked about that. So then what that formula looks like is A sub n equals your first term, 3, plus your common difference, 5, times n minus 1. This can be used to find any term in the sequence. If I wanted the 10th term, we would plug in a 10 for n. If I wanted the 12th term, 12 for n. If I wanted the 150th term, I would plug in a 150 for n. I can find any term in the sequence.